Welcome back. For the next part of this lesson, we're going to do a little work with proofs. So we're going to use SSS and SAS in our proofs. And because these are congruent shortcuts, our proofs can now be shorter. So we don't need to prove all 6 matches. We only need to get 3 matches to prove triangle congruence. So basically the idea of doing a triangle congruence proof is to look for pairs of congruent sides or pairs of congruent angles. So you want to be able to say, I know these 2 sides are congruent and this is the reason. Or I know these 2 angles are congruent and this is the reason. I know it for sure. We're looking to get 3 of those matches, and then we can say congruent by one of our theorems. Okay, so in our toolbox, we have any given information. So sometimes we're just given matches or pairs of congruent sides and angles. We're just told these are congruent. So if that's the case, we can put that in our proof. Another tool we have is angle relationships, and the 2 relationships that we'll use most frequently in our proof are vertical angles and alternate interior. Both of those angle types are congruent. So if we see vertical angles, we can get a match. If we see alternate interior angles, we can get a match. We might also use the reflexive property, which says that things are congruent to themselves. So if 2 triangles share a side, or they share an angle, the same angle appears in both triangles or the same side appears in both triangles, then we have a match because the shared angle or the shared side is congruent to itself. We might use the fact that something is a midpoint or that something has been bisected, and both of those ultimately mean that whatever that thing is has been cut into 2 parts, or sorry, 2 congruent parts. So if we have a midpoint of a segment, we know the segment is cut into 2 congruent parts. If an angle has been bisected, that angle has been cut into 2 congruent parts, so we can get matches from that. And finally, we might use isosceles triangles. If we're told that an isosceles, or that a triangle is isosceles, then we know automatically that it has 2 congruent sides and it has 2 congruent angles. So we can get matches from knowing that triangles are isosceles. All right, so let's try 2 proofs and see how they go. All right, for our first proof, we're given BA congruent to CD and BD congruent to CA, and we want to prove triangle BAD congruent to triangle CDA. So it is often helpful to locate the triangles that you want to prove congruent if there are multiple triangles in the diagram. So we see that there's a triangle here, there's a triangle here, there's a triangle here, and then we have these bigger overlapping triangles. So let's make sure we know what triangles we're actually talking about. BAD, so triangle B to A to D, that's that triangle right there. And then triangle CDA, so C to D to A. So we're looking at those 2 bigger overlapping triangles. And since they're overlapping, sometimes it can be hard to see what's going on or hard to mark the figures. So I often recommend, if you're working with overlapping triangles, to draw the triangles separately off to the side to help you mark your figures. So I'm going to say this is triangle BAD. And then my other triangle is facing the other way. So let's say this is triangle CDA. So that might help us see what's going on when we start marking our figures. Okay, so we've got that. Starting your proof, best thing to do is to look at the given information. This given is giving us 2 matches for free. So BA congruent to CD, I'm going to mark that on the figure. That helps me visualize at the end, whether it's SAS, SSS, or whatever. When we get more different theorems, it will also be helpful to mark so we can distinguish between all of them. And then I'm going to put it in my proof. So I know that I have a match between BA and CD, And the reason I know those segments match is that it was given. Okay, I have another match in my given, BD and CA. So I'm going to mark that on the figure with tick marks, BD and CA, and then I'm going to put it in the proof. BD is congruent to CA, and the reason I know this is that it was also given to me. Okay, so we've got two matches for these triangles. We need a third match. And we see in the figure where the triangles are overlapping that they share a side, right? AD and DA. And we can see that on our separated figure. This side is labeled AD. The side on this triangle is also labeled AD. So we know that AD has to be congruent to itself. So we're going to get a third match here. So AD is congruent to itself. That's the reflexive property. Okay, and now because I have three pairs of sides that are all matched up between these two triangles, that's enough to conclude that the triangles are congruent by our side-side-side theorem. So I can write my conclusion that triangle BAD is in fact congruent to triangle CDA, and my reason is side-side-side. All right, so that was the first basic triangle congruence proof. Our proofs will get more complex as we get better at them, but for this first lesson, we're just going to do basic proofs where we make our three matches and then pick the theorem. Okay, let's try one more. So we're given that R is the midpoint of PT and QS, and we want to prove that triangle PQR, so this guy, this top one, is congruent to TRS. Oops, I just realized these are in the wrong order. Here we go. Okay, so there's only two triangles in this picture and they're not overlapping, so we don't need to draw them separately. We can just work with the figure that we have. So let's start with what we're given. We're not directly given any matches, which means we have to kind of interpret the given to get matches. So we're told that R is the midpoint of PT. Let's just start there. What does that mean? Midpoint means two congruent parts, right? So PT, this segment right here, is being split into two congruent parts. So that means this part, PR, is the same as this part, RT. So I might just start by putting ticks there. I know it's two congruent parts, and now I can look and see, okay, this first part with the tick is just P to R. So in my proof, I'm going to write P to R is congruent to the part with the other tick, which is T to R. Okay, and my reason for that was R is the midpoint. Of PT. All right, so we got the first thing down. Okay, we're also told that R is the midpoint of QS, right? So it's not only the midpoint of PT, it's also the midpoint of QS. So this segment here, QS, that's also being split into two equal parts. So let me just mark those two parts first, and then that might help me know what to write in my proof. So the first part that has the marking is just Q to R. So in my proof, I'm going to write QR is congruent to the part with the second set of markings. So that's just S to R. Okay, and the reason for that was R is the midpoint, but this time it's of QS. So it's a different segment this time. All right, so that exhausts the given information. We have two sets of sides matching up, so we either need the third side or we need an angle. The third side would be PQ and TS, and there's nothing here that's telling us that they are for sure congruent. They might look congruent to our eyes, but we have to be able to say, this is why we know for an absolute fact that they are congruent. We can't just write in our proof because they look congruent. We have to have a more convincing reason. So I think we don't really know that PQ is congruent to TS. We don't have a reason for that. We do have a reason, however, why this angle is congruent to that angle, and it's because those are vertical angles, right? And we always know that vertical angles are congruent. Okay, so I'm gonna get a match by vertical angles. I know that that's my reason. And now I just need to name those angles. So remember, 3 letters outline the shape of the angle with the letters. So I could say Q to R to P, that outlines the shape of that angle, is congruent to angle, and then S to R to T outlines the shape of the other angle. Okay, so that was a match by vertical angles. Now we have 2 sides matching up and a pair of angles matching, and the angle is between the 2 sides. You can see that the green angle is between the pink side and the yellow side. So that means these 2 triangles are congruent by the side angle side theorem. So we can write our conclusion: triangle PQR is congruent to triangle TSR by side angle side. All right, so that's what triangle congruence proofs look like.